Hello, I welcome you all. The problem reads, both problems in fact are coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. We did solve the first problem in the first videos. In the first video, we solved it. So this time around, we are going to be dealing with this one. Okay, this one. So this one is the one we are solving this time around. And the difference in the two is that the first one, the motion was in the horizontal plane, plan view. Okay. While the second one, the motion is in the vertical plane. This is where they were to be pointed downwards. So let's check what we found in the first case. So for case one, which is 13-109, for the first one, we found that the value of n was equal to and it was in this direction like so, right? Was equal to 25.60 newtons, and we found that F was equal to 0 newtons, right? So these were the solutions for the first case. So this time around we'll be going to case number 2. So we want to find, this is 110. Alright, so this is what we are going to be solving. So to start with, let's draw the free body diagram like we did in the previous case. So we are using the polar coordinates. We do have the radial coordinate like so, and we have the theta coordinate, right? Alright, so this is our r, this is our theta. So we do have the force here. This is the force that the rod exerts on the collar. This rod OA, this one coincides with the theta direction. This is F. Okay. And then we do have the weight of the collar. Okay. So this collar is the weight of this collar is the collar that goes round this, that slides on this circular rod, right? This collar here, this one, this is the one we are talking about. All right. Then the force is exerted on this collar, right? Okay. Right. So this is our W. And then we do have the normal force. All right. Before I draw the normal force, let me draw the tangent line because we need it like so. We draw the tangent like so. Okay. So there we go. So we have the normal force like so. So this is our normal force, and it is N. Okay. Alright, so with this information, you can begin to write down the components. Before we do so, you also need to show the angle between R and this tangent line. Okay. Remember that? So we do have this angle here. This angle here that we are going to call, we are calling this angle as psi, and this one is negative, it's clockwise. So if that is the case, then we'll have this one here as our alpha. So with that, then we can simply say n, we're going to have a component of n in that direction like so, and another one in that direction like so, right? And then we'll have w will have one component in this direction like so, and another one in this direction like so. So let's check the angles. So we do have this one here is theta. So if that is theta, this becomes a 90 minus theta, then this one here will be theta. Okay. So let's write down those angles. So this one here will be theta, right? So if that is the case, then this becomes W cos theta, then this one becomes W sin theta. And for these ones here, this one becomes N cos alpha, and this one becomes N sin alpha. Alright, let's say we have a kinetic diagram, direction of our motion in that direction, as well as in that direction like so. So this is our A arrow, this is our A theta. So what do you think here? What do you think about the force in the second case where this is in the vertical plane? You can pause the video and guess whether it will be more than 0 and what will be the value of n. Alright, let's move on. So we know that tan psi is just equal to r divided by the r the theta, and our r is just equal to 1.6 cos theta. Therefore our dr the theta is just equal to minus 1.6 sin theta. Then tan psi is just equal to r, which is 1.6 cos theta, divided by minus 1.6 sin theta, evaluating this at theta equal to 45. And therefore, evaluating this, our psi is just going to be equal to, mind you, this and this goes, and then let's work out this. So we have cos 45, of course, divided by sin 45, which is just a 1, and then tan inverse of that is a 45 minus 45. Minus just simply means our angle is measured clockwise. So psi also means 45 degrees like so, and then if we are to draw this, just means like so, clockwise. Then we know that our alpha is just equal to 90 degrees minus psi, which is equal to just 90 minus 45, and therefore alpha is also equal to 45 degrees. Let's find the values of r. R double dot, we use this for the acceleration in the theta and the r direction. So r is equal to 1.6 cos theta. Therefore, r dot is just equal to minus 1.6 theta dot sine theta. Then r double dot, here we are using the product rule. We can factor out 1.6. We find the derivative of one while keeping the other one constant. Okay, like so. And then plus theta, okay, squared cos theta. Okay. Then we do know that our theta is equal to 45 degrees and our theta dot is equal to 4, and this is constant. Therefore, theta double dot is just equal to 0. Alright, so let's move on. Then our AR is just equal to R double dot minus R theta dot squared, and this is equal to, so let's find these values first before we start calculating. So our R at theta is equal to 45 degrees. This is equal to, that's 1.6 cos 45. This gives us a 1.1314. Then R dot at theta equal to 45 degrees. That's minus 1.6 cos dot is 4 and sine 45. So this is minus 4.5255. And R double dot at theta equal to 45. What do we have? That is, this part is a 0. So we have 4 squared cos 45 by 1.6. So this is equal to minus 18.1019. Alright, so let's find the acceleration in the r direction, and this is equal to r double dot minus r theta dot squared, and this is equal to minus 18.1019 minus 1.1314 squared, and our AR is just equal to minus 18.1019 minus 1.1314 times 4 squared, and this is equal to 36.2043. And we have A theta, which is just equal to R theta double dot plus 2R dot theta dot, and this is equal to 1.1314 by 0 plus 2R dot, and our R dot is minus 4.5255 by theta dot, which is a 4, and our A theta is just equal to 2 by 4.5255 by 4. Okay, so this is minus 36.204. Alright, then we have summation of forces in this equation of motion is just equal to MAR, in that direction being our positive reference. What do we have? So in that direction we do have weight minus W sine theta, then minus N cos alpha. Okay, this is equal to MAR. So this is just minus our mass for the collar is 0.5, okay, by 9.81 sine 45 minus n cos 45 equal to 0.5 by AR, which is just minus 36.2043. Therefore, our n will just be equal to minuses, they all cancel. So we have 0.5 by 36.2043 plus, no, we said all minuses, they cancel, therefore minus 0.5 by 9.81 sine 45. So this gives us, then divided by cos 45. So this gives us a 20.70. So I'll write here what I'm going to use. Write it in 4 decimal places, 6953. Okay, let me repeat it. 0.5 by 36.2043 minus 0.5 by 9.81 sine 45, okay, and divided by cos 45. Alright, so let's apply the other equation, summation of forces in the theta direction, going in this direction being our reference positive. So we have F minus W cos theta minus N sine alpha equal to MA theta. So we have F minus W, which is just a 0.5 by 9.81 cos 45 minus 20.6953 sine 45, then 0.5 by A theta, which is just a minus 36.204. Okay, then we have F in our case will just be equal to minus 0.5 by 36.204. Then we have plus 20.6953 sine 45. Then we have plus 0.5 by 9.81 cos 45. Of course, this gives us a 0. 0.000123, yes, something like that, which is technically just approximately equal to 0. So our F still remains equal to 0 newtons, and our N is equal to 20.70 newtons, and it goes in the same direction. So let me check this again. So minus 0.5 by 36.204 plus 20.6953 sine 45 plus 0.5 by 9.81 cos 45. Alright, I think this is about it. So we still have a 0, and the only thing that changes is the normal, the reaction force, the normal force, N. right? So in the first case, it was higher, but once the weight of the collar was included in the vertical plane, the normal force reduced. So I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.